record. Awesome. Okay. Can you guys see my screen? Okay, I see some thumbs up.
Yep, we're good. Yeah, sorry.
Yeah.
Awesome, thank you. Cool. So let's jump in. So dates and times in JavaScript, what we want to be able to do today is get an instance of a date, know some of the methods available for the date object and how to manipulate a date object, and be able to set a date. So the simplest, in the simplest form, we can create a date by declaring a variable, so like now equal new date. We need to invoke the constructor of the date object. And let's console log now. So we run this, and we get this printed onto the screen here. It is not a string. This is just the representation of the date object. So it turns out that actually internally, the date object is stored as a number, as the number of milliseconds from January 1st, 1970 at midnight. And we'll talk a little bit more about that. But this is a date object that was just created. And this is the value for that date. For instance, if we want to get the number of milliseconds, then we can do console.log now that get time. Get time is a method in the date object that will give us the number of milliseconds. So sort of like the internal value. So if we run this, note that actually, I don't know if you noticed, but the date actually changed. And this is the number of milliseconds that have elapsed since the 1st of January of 1970 at midnight. And why that date? There's a lot of historical reasons for it. That's like, but I don't want to get into that. One important thing here is you see that this date. So today is August 8th, the 8th. So then we have on the first component here, and we'll talk a little bit more about this as we go on. The year, the month, the day, and then after the T, we have the time. And you can see that it's 14:31:57. So this is like in military time. I don't remember what's or a 24-hour clock time. And you see that 14 will be the 2 p.m. But it's not 2 p.m., it's 10 a.m. The reason for this 2 p.m. Is because this date is being shown to us as from like this is the date. This is the time and date at the Greenwich mean time. This is the time and date for the Greenwich mean time. And what that means is, actually, let's get into a little bit of this. Time zones map. So the world has different time zones, as you might already know. And these time zones are more like for political reasons I actually was reading than like anything else. There is sometimes it's better to have like clock aligns for political and business reasons. But for instance, this is UTC, and then also UTC and GMT. You're gonna see those two, UTC and GMT. When we're talking about those two, we're talking about this sort of the Greenwich meridian is in here, which is roughly like half of the world if we look at it from that way. Here, then at this moment, we are here in New York. We are in New York here. You can see in New York, it actually sees this map. It's 10:34 a.m. If we go to the Greenwich zone or UTC zone, which actually you can see that England is running, even though I'm on England, the United Kingdom, the +1 is the one highlighted. Let's go somewhere here. We can see then that there, wait, actually like this country is here. We can see that there is Timbuktu. I remember this came the other day conversation. Anyway, you can see that there is GMT, and I can't highlight it, but it's GMT, Greenwich Mean Time, and there is 2:35 p.m. So as a reference, we oftentimes use this time as a reference because, you know, so that we don't have to care much about, like, you know, if it's 10 a.m. in New York, what time is it in China or in Russia? What we could do is we could just agree on like UTC, and then each one of us then subtracts a certain number of hours depending on our time zone. So in New York, you can see that that's where this -4, -3, -2, and -1. In New York, which is this zone, well, actually, New York. Yeah, New York is -4. So you basically take the time from GMT or UTC, and then just subtract 4 from that, and then you got the time from New York. So we saw that here we have 4:31 p.m. We subtract 4 from there, and we subtract our time zone, which is EST for Eastern, or ET, Eastern time. And then we get that. So you see, like, sometimes actually, and this is actually something that I haven't, maybe you guys know a little bit more about it. I don't remember exactly when. I do remember that at some point, Colombia, where I'm in Colombia, my family in Colombia, and in here in New York, we're on the same time. Right now, I think we are 1 hour. We're 1 hour ahead right now because of the, is it summer daytime? What is it called? EDT, Eastern Daytime. Is that correct? Joey, was it you?
Daylight savings, but yeah, it switches
I
from
think it's EST.
Yeah.
It's Eastern Standard Time.
And EST is 5 hours behind. So, oh, also, I should have also mentioned this. UTC stands for Coordinated Universal Time. It actually, there's a difference between UTC and GMT, but for practical reasons, there is none. The UTC is a standard. GMT is actually a time zone. So this here should say GMT as a time zone. So with this times and around this meridian, we just that will be UTC or GMT. Right. So EST is 5 hours behind, but right now we're in DST. Is that right? Daylight saving time. Okay, so basically the world is divided like this in time zones, and the standard is around this, the Greenwich meridian, and that's what we get when we do this in here. So this date, since we took it a few minutes ago, but that's that date. Any questions or thoughts so far? And this is the number of milliseconds that have elapsed since, again, January 1st, 1970 at midnight. Okay, let's keep going here. Okay, so you can do that. Let's look at this method toString. Let's actually do that here. Console.log. Now that toString. Also note that right now, when we created this date object, it was 2:31 in the UTC time zone. So run this again, that's going to change because this ran at a different time. Now we are 8 minutes after that. And note this here. What do we see here? So basically here we just have a more readable, human readable representation of the date, Saturday, August 8th, 2020, and the time. And we see GMT plus 00. That means we are coordinated universal time, also UTC. 00, this, you will see this plus or minus, then that means the offset from the middle. And we'll see that. I actually think, well, let me run this in Node, see if we get a different result in my computer. Because I was actually kind of expecting something different. Let's see. Yeah. So as I run this in Node, even though like here in REPL, I'm running it in Node, but that node, we don't know where that computer is. But note here something interesting. As I did note now, and I console log that, I get this roughly the same amount of milliseconds, a few more or less, for the time that I spent. But here, when I do now that to string, actually I get this different. Saturday, August 8th at 10:41 a.m. and GMT minus 04 Eastern Daytime. So I guess something that this is telling us is that the toString method, what it will do is it will give you a human readable representation of the date in the time zone you're on. So Node will check what time zone you're on and this do the offset for you, like do the math for giving you the actual time. So you see that now is 10:42 roughly. So this is, I'm thinking the one that I'm running on REPL, we don't know where that computer is. So this could suggest that it's maybe somewhere in that meridian, but I'm also thinking maybe the people that made REPL also do some configuration so that they set the, so that there's no local time because you don't know where this computer is, basically. But the toString will give you a representation of the string on your local time. So even if I have, and this is also true in the browser. If this is just because I'm running it here in Node, but if I open a new window here and I run this same stuff here, we should say something similar. Should see something similar. Yep, we see the interpreted GMT minus 4. That's our time zone, and then this is the time. Any questions or thoughts so far? Yep, Douglas.
So the so no matter where this, so this will be run locally. So if you're running JavaScript as part of a program in someone's computer and they're over in Texas, it'll grab their local time versus the time of wherever the Heroku server is or wherever it is.
It will, the best way to think about it is it will grab the time, no matter where you are, it will grab the time on UTC. And then it will do the offset for you so that you don't have to do it yourself. Like whenever you do toString, so that can get a bit confusing, but just know that whenever you create a date object, you're gonna have the UTC representation, which will be the same for everyone. And then from there you do the offset and then figure out what time it was where. Yeah, but it will be dependent on the on the machine where you're taking the date on. So if you're taking the date, for instance, in Heroku, let's say it's your backend server, the one that's create a new date whenever somebody adds something, then you'll need to be you'll need to know where Heroku has that computer. Or what you could do is just save the date on UTC, or on we're gonna get into that. Save it into a format called ISO 8601, and then from there you just know that will be the time in UTC. Then you can call it toString on one computer in some part of the world, and it's going to give you the right time, and call it toString in another part of the world, and that's going to give you the right time for that. Mm-hmm. Okay, so let's keep going here. So this is how we can take a measure of like the current time. If we want, we could also create a date like this. We just need to pass in a year, a month, date, hours, minutes, and seconds. So let's take a look at an example of that. Now I'm wondering if we should do that here or in Node. Let's keep going here. Somebody give me a date.
December 28th.
Okay, so let's do and what year?
1993.
Date. So we can then, the first argument is the year, 1998, you said?
93, but it doesn't matter.
93. And month, you said December.
Yes.
Right, so the month here, so we can create a date of right now with this, with calling the constructor object with no argument. If we want to create a more specific date, then we can pass the components of the date here. The first one is the year, the second is the month. Now, one interesting thing to remember here is that months are, you can think of it as 0th index, basically, here. For the year, we must specify the 4 digits. For the month, January is 0, December is 11. So then December, and the days, the day parameter, if absent, 1 is assumed, and that can be, what day did you say, Peter? 2nd?
28th.
28th. Got it. So let's take a look at this. This console log. What do you think? Anyone want to guess what we will get when I do pit state toString? To any part? Maybe it's kind of, I don't know if anyone knows what day that will be, but that will, yeah. Maybe Peter knows, but I'm not sure everybody else.
I think it's a Tuesday, but I could be wrong.
Okay, let's take a look. That's right, Tuesday, December 28th of 1993. So whenever you don't pass a time, midnight is assumed, but actually, like, this is midnight. This will be midnight from the previous day, right? I guess, or is this like, well, the 00th hour, the 0th hour of that day is assumed, rather than saying midnight, because it depends on how you look at midnight. When I think of midnight from the day before. So this time for me will be, or like 23:59 will be like, for me that will be midnight of the day before. But anyway, this is the 0th hour of that day basically. And again, this is giving me, actually I think we should do this in Node or in Chrome at least. Yeah, we should do this in, let me open VS Code. Cool. So let's run this. Yeah. Okay. So let's comment this one. We get Tuesday, December 28th, and it's also that's actually kind of interesting because if we see here in Node in REPL, it gave us the same date. And again, this is more of the configuration of REPL than anything else. But it gave us Tuesday, December 28th of 1993, the 0th hour. But this was in UTC time or GMT 0. And here, when we run it in my local machine, it's giving me the same date, but now there is the offset, interpreted as my local time, which is Eastern Standard Time. Okay, so that is one. Then we can specify hours, minutes, and seconds as the other arguments. One interesting thing here, we can see it here. Let's say hour 25, minutes, say 40, 30, and you can even get to the milliseconds. Let's put 100. You see that yeah.
I'm sorry, super quick question. The so this output that we're getting, the string that we're getting returned, that's a standardized return, right? It's always going to be Tuesday. It'll always be the day of the week, the month, the like the day, like the numer, like the day of the month, the year, okay, cool.
That's right. This will always give us the same sort of format. But this is a format. This is a format that we use to display dates to the user. We actually should not use this format for saving the date, for instance, a database. We're going to see ISO 8601 is for that one. Yeah, but I made a mistake here where I put 25 for the hour. Actually, so let's see what that gives us actually. Node.js, and it turns out that then we get self-correcting, which you have to be careful about. Of the date. So we see that the date moved to December 29th, now is Wednesday. So what it did was it actually folded that 24 onto the next day, right? So if the maximum hour will be, wait, let's see, what do we get this? 24. Yeah, okay, this gives me the same one. Wait, I'm getting confused myself. We'll put 26. This is interesting. So if I put 25, so the maximum hour of a day will be 24. No, like 23 and 59 minutes, right? And if I do 25, what that will do is actually going to make it 1 a.m., 1 hour of the next day. What I find, I guess, a bit confusing is if I put 24, I was expecting actually, if I put 24, oh, okay, yeah, then I got confused. If you put 24, then it just gives me the 40 minutes on the next day. Because, you know, there's no the 24th hour and 40 minutes of that date. 24-hour doesn't exist. So it just sort of falls it onto the next date, and it increases automatically the date here. That is sort of something we have to be aware of whenever you're passing values here. The date will sort of self-correct, self-accommodate to fit. And that's also true. For instance, like leap years and month, I forgot the name of those months that sometimes have a different number of days. What are those called? Like February, I think, is 1 month that some years has 28 days, some other years have something else. What are those months called? I guess we could just ask Google.
Leap years.
But that's okay. Okay, I guess it's more like leap year. So on a leap year, then February has 29 days instead of 28. JavaScript will handle that for you. So if you try to say the 29th day on a year that's not a leap year, that's probably going to give you, so maybe we can try it. I think that will give you the 1st of March. Let's try it out. Leap year. What is a leap year? It's 2018 is a leap year?
2020? No.
Okay, let's do that. So let's put a new date here. Leap year equal new date 2020 to 29. And let's see what time. 15, just like this. Now let's do leap year toString. Run this. Oh, what did I do wrong? Why is it giving me this? It's giving me March instead of February.
You forgot 0 is the first index.
That's right, 0 is January, so this 2nd is March. 1st will be February. Let's try this. Okay, we got February 29 at 3 p.m. Now let's try then not a leap year. Let's see what we get. 2019. Oh, so we see that then we got March, actually March 1st of 2019. So yeah, that's stuff that you have to be aware of when dealing with dates. But on the other hand, it's good that JavaScript takes care of that for us, and we don't have to think, but we do have to be careful and be aware of that. So if I try 29th February of a year that's not a leap year, it will fold the date to the next day, March 1st. Oh,
I remember there was a big problem with that on Robinhood, where they coded wrong and didn't account for leap day, and it cost their investors a bunch because people who were like, it locked people out of the system. They didn't think leap day existed, so like suddenly it was a day forward, and no one could, and they lost a ton of money, and they had to try to fix that up, and it was crazy.
yeah, dates are tricky. Cool. So let's see. Whenever you want to create a date, that maybe it's not in one of the formats that we'll see, this is the best way to create that date. I actually had to use this recently for one of my projects, where I have a date. Yeah, actually, maybe we can take a look at this. I have a let date str, and I have a date like this, 2020 08. I have a date like this, and I cannot feed this. What happened? I cannot feed this date directly onto my constructor. We'll see what. Actually, we'll see this next. To get dates of the components of the date, then if you want to get the year, you can do get full year, get month. Remember that gives you 0 for January, 11 for Saturday, for December. Get date, the day of the month, from 1 to 31. It's a bit, yeah, the name is a bit weird, but it gives you the number of the day. Get hours, get minutes, get seconds, get milliseconds to get those corresponding parts. Get day gets you a number from 0 to 6, where 0 is Sunday and 6 is Saturday. So this is if you want to access specific parts of the date. Also, you can set it, like if you don't have it at if you can start an object like this, a date object like that, and then set individual components at a time with these methods. Set full year, set month, set date. So for instance, if we had this full year, let's do this. Let's do leap year that set full year, set the year to 2020. And then we can run this, and we see the first one. Oh, this is interesting. Set full year 2020, 2019. This is actually kind of interesting, and the reason why dates can be tricky. But we see on the first one, let me clear this. We saw that on 2019. Oh, okay. So this is weird, but let's see why we get that. So on the first year, we had 2019 and February and the 29th. The 29th doesn't exist on 2019 because it's not a leap year. So what happens is the date gets moved on to the next date, and then we get March 1st of that date. And for some reason, I was expecting this to be, instead of March 1st, actually be February the 29th, but I forgot that this is what will make it fall onto the next one. And that is then modified, the date, to be March 1st of 2019. And then what I do, when I set the year, I'm just setting the year to 2020, then is the same date, is March 1st, because it was set before, but now it's a Sunday, because now we are in 2020. But with these functions, then you can set individual parts of the date. We talked about the self-correction when you have like, this is another example, like January 32nd, that doesn't exist. Then that moves on to February 1st, in this case, 2013. Let's see what else. Here, get date, set date. Here, this is an example where we are increasing a date by 2 days. We can see the set date. Set date will let us set the actual day, the number of the day of the week. So this is something we can do to do sort of like date math, basically. What we're doing here is we get the day, which is the 28th here of February, as we talked, and we want to add 2 days to that. What is that day plus 2 days from that? And as we said here, as we were looking at in the example, that can be either, it depends on whether it's a leap year or not. Because if it's a leap year, then this will be the, if it's a leap year, it will be the second, that day plus 2 will be the 2nd of March. If it's not a leap year, it will be the 1st of March. Let's actually take a look at this quick example as well. JS. So we see, let's actually do it with the example that we were looking. 2019, not a leap year. So we get March 2nd. So that day, the 28th plus 2 days. If it's a leap year, like 2020, we get March 1st. It's a Sunday. Cool. Okay, any questions or thoughts from these examples we have seen so far? Okay, so let's take a look at parsing a date from a string. So we could parse a date from a string as long as it's in this format. There is a few different formats that are sort of allowed. This is this is the simplest format. So we could do this. Let's say console.log data to string. So as long as the format is in this, like the year first, then followed by a slash, then the month, then the day, then followed by the time with separated by colons and a space, then that day will parse correctly. So let's see, Node.js. Oh, did I save? No. Let's say Sunday, July 12th of 2009 at 12:34. Now, one thing here is this will be interpreted as local time, so that's why we get Eastern Daylight Time. We cannot specify a time zone here. We're going to see that in the next one. So this will be interpreted as local time. Now, if we want to know what this date is in UTC or GMT, what we could do is just console log the A for the date, and we'll see then like the UTC representation. And that UTC was gotten from calling ISO string. Actually, ISO string will get us the same thing, just in an actual string. And this is something where you're gonna come across sooner or later, the ISO format. And actually that's our next format here. So also like important notes here, this format doesn't allow for milliseconds. So if you need to parse for milliseconds, you can't do it that way. Only Chrome handles milliseconds at the moment. The date is interpreted to be in local time, GMT, I guess. You can specify a time zone offset. So basically, if you have a date in this format, like this string, you could parse it like that. If it's in a different format, the recommended approach will be you split it manually and then feed it into the date constructor yourself like this. Now, the other format that you can parse is in the ISO 8601. This is a standard, an international standard for date be transmitted. And this includes the time zone. So the format here is also simple. Instead of slashes, you have hyphens, and the hours or the time is separated from the date by this T here. And then we have something like this. July 30th, for instance, 2020, July 30th at 5:44 a.m. Now let's take a look at this then. Console log. Cool, we got July 30th of that. And note here though that we have this format has the Z, which is where we can specify the time zone. Note here that in here, this is being passed to be interpreted as UTC. That's what the Z stands for, is 0, basically. So no offset from UTC or no offset from GMT. So you see that this is 5 a.m. of July 30th in the UTC time zone. When I print it to string, which is going to interpret it on my local time zone, then I get that in my local time zone, that time is actually 1 a.m. So when New York is 1 a.m. in UTC, and the UTC time zone is 5 a.m. Right? Because we're 5 hours apart. So the Z stands for 0, and that's how you can specify a time to be interpreted in UTC, and in the UTC time zone. If you want to specify a time zone, then you can also do that. And you can do that by, instead of the Z, put in plus or minus in the amount of hours you want. So let's do an example here. So 5 a.m. Oops, I had to plug this thing. Give me 1 second. So this is then 5 a.m. in UTC. Let's do another date. This is time. Let's actually pick something from here. Let's do like Australia. Where is Sydney? Does anyone know? Sydney, here we are. Okay, Sydney is plus 10. So that's quite a large offset. So let's do that one. So what we could do is, let's do Sydney time. Is that how you spell it? Sydney, that's right. So Sydney, let's say, actually let's do this one. Sydney is 1:13 a.m. So let's do 1:13, and then when this is, if we leave the Z here, then this will be 1:13 in UTC. But we actually want it on the Sydney time zone, so we can change the Z by a plus and then the number of hours, which is 10, the offset 10, and we also need to specify the minutes. And let me go back here. That's right. Okay. So let's take a look at this. There's now console log Sydney time. There's also console log Sydney time that toString. And let's run this node. So let me also comment this guy out. Node lesson, and we have this. So in UTC, that's the time. In UTC, it will be whenever in Sydney is 1 a.m. On the 30th, right? In UTC is 3 p.m. on the 29th. And our local time, actually, let's do this in, let's do our current time. Today is August the 9th, 8th. So that we have a current time. So let's do a lesson. Oh, right. So when in Sydney, Australia is August 8th at 1 a.m. In UTC is the previous day, the 7th at 3 p.m. And that's in UTC. And our time in New York time, when in Sydney is 1 a.m. on the 8th, in New York is 11:13 on the 7th, 11:13 in the morning. So this is then the ISO 8601 format. This is the format that you should use to save your dates to your database. Generally, you do you save it in UTC time, and then in the client, you then take that into your local time to display to the user with toString, for instance. So this is then how we can parse a date that is in the UTC format, not in the UTC, the ISO 8601 format, and then let's see how to get that one. Also from here, there are a lot of nuances with dates in different browsers. So I found this really good table here that explains some of that, which might be good for your reference. So all the browsers, or most of them, interpret these dates correctly. So if you have this format, this was the first format that we saw, this is going to give us the right result. Now we specify milliseconds, then only Chrome knows milliseconds. Older versions of Chrome and Firefox or Internet Explorer don't understand those. This format works well in all of them, but note that all of them are interpreted in local time. So that's something that we have to be aware of. When we get into more, then there is more red areas where Firefox doesn't do well. Then these other formats, you shouldn't even use them because you can see that there is not a lot of support for that. ISO 8601, which is the format that I'm recommending you to use when you save dates on your database, they are all interpreted in UTC unless you specify the specific time zone offset. And they work well on modern browsers, which is like Chrome 12 and forward. And recent version of Firefox. Firefox 1.2.3 and 4.2.9. 1.2.3 doesn't work, but on recent versions of Firefox as well, those work well. In Internet Explorer, this one works fairly okay. The explicit one, Internet Explorer doesn't know how to handle this. But with browsers being, the browsers that we target being more current, ISO is the date to go with. In fact, if you've ever used the now function in Postgres, that's going to give you a date in the ISO 8601 style or format. So just, when in doubt, consult this table. Another alternative is using a library like Moment.js. I think I don't remember if it was Hugo worked with Moment.js for Capstone project. Moment.js is a library that handles dates as well in many different ways. It has a bunch of really nice features. And I think one of the features is if you want to, like this relative time, like 20 minutes ago, 9 years ago, and stuff like that. This stuff that you can still do with dates, but it's just easier if you use something like Moment to specify, to display. So yeah, just know that something like Moment exists and you can use. Okay, so displaying and serializing this, we sort of talk about it. To string, it's a format for a user to see. To local string is actually interesting because to local string, what it will do is it will look at the locale of your machine in the browser, and it's going to give you the date in that format. Let's actually take a look at this. So for instance, to local string, you can actually pass also the locale and a time zone. So you see that in England, the day goes before the month and then the year. But in Korea, this is the format that that Koreans like look at dates on displayed. The year with a colon, space, a month, colon, and 20. No, not colon, period, and 20. And I don't even know what this is. But okay, so this is the local string. Whenever you're displaying dates, maybe like if you're building a website that is used in different regions. For instance, like I remember when I moved to America, this is the way that I used to look at dates: the day first, then the month, then the year. But in America, then I realized it's reverse. You go for the year first, then the month, then the day. And it took a little bit of getting used to that. But yeah, then the local string will actually interpret the local. If you don't pass any arguments, it interprets the local from the system, and then it gives you the date in that local. But you can also pass it here, and it just gives you a string. So to string we saw, then this one to ISO string. So to ISO string, it's going to give you the date on the ISO format. So if we do console log Sydney time that to ISO, when we run, we see that we basically see the exact same thing that we saw here. It's just that this is not this is just this is Node seeing, oh, you kind of want to console log a date. I don't think you want the milliseconds. I'm just going to give you this, and I'm going to color it purple so that you know. But when we actually call it to ISO string, then this is the actual string. Sunday Sydney time. Let's see what if we do like type of Sydney time. Yeah, it gives us an object because we have a object date. Okay. Cool. So whenever you're saving dates into a database, you have to take into account use the ISO 8601 format. Don't use a time zone. Just use the UTC time zone. because then from the UTC, then you can offset from others. And then the other thing is, it might matter where you take this time. Right now here, we're taking the time here in Node. So it might matter where you take the time, because if you take the time, wait, actually, hold on. No, as long as you are using the UTC format in the ISO 8601, it doesn't matter where you take the time. It doesn't matter if you take the time in the back end or the front end. It doesn't matter if those are in different time zones, because you're using the UTC, you know you're going to get the right date. And then that date you can save onto your database. And you can see, yeah, you can see an example of that in here. I actually have, so code. We're about to be over, and then we can do some questions. You can see that in this database that I have here, which is part of one of my apps, it has a journals side and it has an entry endpoint. When I execute this, you can see that I have a TS field, and this is a date in the ISO 8601 format. And if I go to Postman, actually like Postico, this actually got me confused recently. Oh, I don't have server running. Okay, maybe I can't show you that right now. Oh, I think the other day I was messing with the configuration for this and it broke. Yeah, but this is the date. This is the way in which I save that. The way in which I'm doing that actually is in here. Let me also show you that. Code. Migrations created at. Well, this is an example in SQL, for instance. You can create a column, and I did timestamp. This can actually be something like, this can be abbreviated, and I learned this later, but this can be abbreviated to this timestamp TZ and default now. This line and the line above is exactly the same. I'm saying I had a column created at, which is going to be a timestamp with time zone. That's the TZ for, and do the default to be now. So in fact, let's do this really quickly. If I do select star, should select just now, I think. You see that I get this date, but this date is being, you see that this date is not in the ISO 8601 format, but it's not in that format because pSQL is interpreting it and giving me my local time. You can see that my local time is 11:28. But under the hood is actually stored in a string with the ISO format. I think I'm not sure how I could show you that in here, but this is the local time now. If I save that, when I save that to my database, whenever something gets inserted, and I get it back, I'm gonna get it in this format, the ISO 8601 format. I'll actually see if I can point you to the documentation for that. Now, Postgres now function. Let's see there. ISO. Oh, there seems to be only one match. But let's see. Now timestamp with time zone section current date. Yeah, I can't seem to find exactly what I'm looking for. But also, I guess something here is, yeah, there's many configurations you can do here. Specifying a time zone, and with or without time zone. Okay, so the last thing here is this example here we could do to, if we're curious about how long something takes. This is a simple example of that, where we are taking the time right now, and we say like we set a variable before equal to a new date, and that's going to be the date which this line runs. Then here we just have a simple loop, adding the numbers 0 to 10,000, and then we take the time after, and then we just do after minus before, and that's going to give us the milliseconds that passed. And then we can console log to see how many milliseconds that took. Let's do this one really quickly. Let me close this. So let's take a look then here. Oh, great. This happens so fast that it doesn't even register. Oh, there we got something here. Put a larger number. And that one took a little bit more. That took 1.4 seconds, or 1,448 milliseconds. So this is a way in which you could sort of do some simple benchmarking to see how much something took. Now, something here interesting is the fact that these are two date objects. This before and after are two date objects, but we could still do math in them. After minus before. That is because internally, as I said at the beginning, the date is stored as the number of milliseconds that have elapsed from the 1st of January 1970. And this is JavaScript cleverly seeing, oh, you want to do, you want to subtract these two dates, and under the hood, they're just a number of milliseconds. I know how to do that math. How we can do it. Again, then internally the dates are stored in a number, the number of milliseconds pass from January 1st, 1970. That is it for today. Any questions or thoughts on dates?
I'm not sure I fully grasp how to get a local time from a user to be able to do that adjustment from GMT time to their local time.
So give me an example.
I've got a user here in New York, but I don't know that. I've set my program to know like the standard time, the GMT. Mm-hmm. How do I know that my user is in New York to be able to adjust to that time zone? Like, is it grabbing from their local computer, or is it like, how do I make that adjustment?
So you can't know. Okay, I was gonna say you can't know where the location of the user or the time zone of the user from the date. But you actually could, if you specify the time zone with the specific timestamp. So I guess like, so what I'm trying to see is, so in your database, it's easier if you have all your timestamps or all your dates in the ISO 8601 format, right? And if all of them don't have a specified time zone, or rather they have the Z as their time zone, which is UTC. If you have that, then if you have a date like this, then you don't know where the user was when they entered. You know the exact time when they did that, but you don't know their time zone. You could store the same date, but with the time zone, like here, if we do -4, keep forgetting, like this, then we will know that they're in this time zone. We don't know if they're in New York because there's many cities and parts of the world in this time zone. We'll know that they're in this time zone. I'm just thinking about like where you want to do or why you would want to or not want to do this. I do prefer to keep all my dates in with the time with the time zone of UTC or GMT. And I'm wondering, for instance, like if I query my database, I think this might be true, but we'll need to verify it. When I query the database to get, let's say, all the posts that happen on a given date, that is always tricky because then we just need to investigate, because what I'm thinking is, would the query match, will the query interpret the time as the local time? So even though this is this time, and the server, let's say the server is in Sydney, then will this time, I think what will happen is this time will get converted to local time, and then the match will happen after the conversion. I had an example like that where, actually I could show you here, I think. If I go back to and fire this, I actually struggled with it a little bit recently, where I have this here where I can pass in a date just like this. So yeah, so you can see here that this I'm getting does this really apply? I think so. So I'm getting this date, and I want to get all the journal entries in my database that match that. And I'm not doing simple. I'm not splitting this string and seeing if this matches. I'm not doing that. In fact, I couldn't do that. And then the other one is 31 is 30. No. Which one was the one? I don't remember it at the moment. 2020 801. I think maybe it was this one. Yeah, this one. So you see that the string that I have in database is this 2020-08, 2nd of August. But you can see that this was throwing me off because, well, I specified this. Is this really correct? But it turns out that it is, because the server is converting this to local time before it matches it against this. When the server converts this to local time, then it will see that it's actually the 1 a.m. in UTC is not 1 a.m. in UTC is like, I think it's 9 p.m. in EST of the previous day. So that's why this then matches. Here, let's actually do that. Say node let d equal new date d to string. Yeah, so we can see that this date that I saved as UTC in my server, when it's interpreted in my local time, is actually the previous day, August 1st, at 9 p.m. And that's actually what I wanted in here. I wanted to match anything that was added on this date, from the perspective of the user that's in that time zone. So I'm not sure this adds a lot of context, but this is something that you might encounter at some point. The server, so what's doing here is that the server saves it in this format, but before we do the query, it will interpret that as the local time of the server and then match it against this. This is a small thing there. Going back to your question, Douglas, about like the time zone of the user, you could have in your database, you could have strings like this with different time zones. I'm just wondering if this actually will be an interesting experiment. I wonder if I have a string like this in my database, when I get it, would I get it in this format instead of the original one? The important part is that whenever you save a date to your database, don't save it as a varchar or as a string. Save it as a time zone. Did I close that already? I think I closed it. Make sure that you have a column that is not time zone, timestamp. I mean, timestamp with time zone. Don't save it as a string. If you save it as a string and you chop this off, then you're gonna have different weird results. Yeah. So I don't think that was super good response or answer to your question. But I hope added a little
No,
bit more.
I think I get it. I was just trying to figure out whether or not it has to, like, if it's grabbing from a user's computer their time zone somehow for that. But I think it's more along the lines of maybe, because I'm thinking on times when I would theoretically where I would need to use this. If I'm making a post or I'm doing something that needs to know my local time, usually when I set up an account, I have to be explicit about like where I am, like where am I located. So that's probably how they get that time zone to make that equation on the back end to adjust for times while keeping everything to UTC.
Yeah. So like whenever somebody adds a post on Facebook and the date is stored, that is probably just being stored in UTC time. And that's why then if I'm in New York, then I'm gonna say, oh, this person posted this 2 hours ago. And if I'm in, like, this is maybe I'm not sure this is a good example, but if I'm in New York and somebody posted something 2 hours ago in Facebook, then I'm gonna see 2 hours ago. And that still applies if I'm somewhere else in the world and somebody posted something 2 hours ago. So I guess what I'm trying to say is that use UTC to keep your dates in, and then whenever you want to display that date to the user, the toString method would automatically translate that to their time zone, and it was going to show them the right time. Yeah, and it is mind bending a little bit on like getting used to all the ins and outs, but yeah, that only comes with practice altogether. Yeah, so a few exercises that I would like you to like just take a look at is this. Like, find what is the oldest date you can represent in JavaScript. What's the largest, the most futuristic date you can represent. Calculating dates. For example, what happens in this case. What's your birth date in ISO 8601 format? What time was it in UTC when you were born? So let's do these exercises. Let's take 5 minutes for it, and then we'll close off. And then I'm gonna call on you to answer some of this. So if you have any questions, this is the time also as well to ask them. So research and explore these questions.
Can you post the
Mhm.
link for the
Sure.
free? Thank you.
Zoom chat. Cool. Just put it in the chat here in Zoom.